Okay, I think hopefully we'll get started. I think we're just letting in a few more people. Okay, I think we'll get going now. So good afternoon, everyone, and welcome to today's webinar. So my name is Liv Hoyland, and I'm a soil consultant at Arcadis, and I'm really delighted to be chairing this panel discussion on a topic that's really both quite timely and critically important. So as I'm sure you're all aware, the title of this webinar is Recognising the Critical Role of Soil for Biodiversity Net Gain and Sustainable Development. So soils are really often quite overlooked and undervalued, and development projects historically really see them as sort of an obstacle to be removed or to be stockpiled. But in reality, soils are really a vital living system sort of for the support of biodiversity, climate resilience, water management, and so much more. So I feel like if we really fail to properly understand and utilise these resources, we're actually starting to risk missing opportunities to create sustainable habitats, optimizing circularity, and really delivering those lasting environmental and social values. So fortunately, we are starting to see some progress in this area, thanks to efforts from organisations such as the British Society of Soil Science, also from IEMA and the Soils in Planning and Construction Task Force. And we also sort of have recent updated guidance, such as the CIEEM EcIA guidelines. And this has really sort of started to help highlight the critical importance of soils in planning and development. But obviously, as always, there's still a long way to go in changing perceptions and improving practices. So that's really what we're going to be here to discuss today. And we're very fortunate to have a great panel of speakers who will bring a wide range of perspectives and expertise to this discussion. So firstly, we'll be hearing from Bruce Lascelles, who is the UK Director for Climate and Sustainable Land Management at Arcadis. He is also the past president of BS and also the current president-elect of the International Union of Soil Science. So Bruce will be sort of setting the scene, just exploring how soils are perceived and their critical role in sustainable development. And then we'll be moving to Jess Potts, who is a soil consultant at Arcadis. She's also a member of BS and part of their outreach committee and the new EDI rep. And she'll be sharing some insights and sort of case studies on actually how we can better manage and really reuse these soil materials in a way that we can then maximise outcomes for sort of biodiversity landscape or climate resilience. And then finally, we'll be hearing from Sam Bauer, who is the head of sustainability, so including ecology, biodiversity and arboriculture at Balfour Beatty. And Sam will be focusing on sort of practical approaches to integrating soil management within construction projects, and also looking at sharing a few sort of lessons learned and how we can close that gap between soil science and actually on-site implementation. So after the presentations, we will open the floor up to some questions. So please do use the Q&A function throughout the session to sort of submit any thoughts or queries. So yeah, I'm looking forward to getting the webinar started. So I'll hand over to Bruce.
Brilliant. Thank you very much, Liv. I'm just going to share my screen. So hopefully you can see, you can all see that. Yeah, so Liv's kind of set the scene a little bit, and I'm going to just add to that, around that sort of the point around the critical role that soils play in so many aspects of our lives. And perhaps I'm going to cover perhaps more the why we need to be talking about this. And unfortunately, that does require us to look at what the current state of soils is and why soils have suffered, in order for us to start to understand what the solutions to some of the problems we face need to be. So I'm going to kick off with perhaps a look at this concept of the Anthropocene, what people are calling this epoch of humankind. And I'll then look at the concept of soil health and some of the pressures that soils have been under and continue to be under as well. And then start to think about, okay, well, what are the sort of recent policy advancements that are going to, sorry, excuse me, help enable us to move forward? And I've got just one example of a good practice to share with you as well this morning. So the Anthropocene. This is really a concept that relates to the point in time where, as people are talking about, the human-made stuff starts to outweigh all the life on Earth. And there's obviously, you can see from some of the stuff on the screen here, a large degree of uncertainty in this, but the consensus seems to be that we reached that point in 2020. And this has come about both through population growth and the development that goes along with that, but also as well as a reduction in natural biomass as a result of deforestation and that sort of reduction in our natural spaces and the impacts that we've been having as a result of our development on those natural spaces. And this is not only eye-opening, but I think it also really highlights the current and therefore probably likely future pressures on the natural world, and really that kind of absolute criticality of reversing the decline in biodiversity and reversing those negative impacts on soil health. And we've clearly reached a tipping point. It's a phrase that's been used before. I think we can call this a tipping point. And so hopefully this aids that realization that we need to find solutions, and clearly driving and delivering biodiversity net gain and sustainable development are going to be really central to help achieving this as well. And you can look at this in terms of from another sort of perspective, and this concept which many of you may have come across, these sort of country overshoot days. And I've just put on the graph here the most recently published information in relation to this. And this essentially shows the date on which Earth overshoot day, essentially when we're using more than we've got, would fall if all of humanity consumed like the population of a given country. So you can see on here that if we all consumed at the same rate as Qatar, that date would fall on the 6th of February, so a date that's already passed in the annual calendar. If we look at the UK, this is now the 13th of May, and that's quite a shift from the estimate from last year as well. And all this kind of sort of builds that picture of we have a problem and we've got to be doing something about that. But I suppose that then leads on to the question of why am I raising this in relation to soils? And I suppose this comes back to the part of that title of this webinar, that critical role of soils in so many aspects of our lives. And I really like this concept, this soil life nexus from Professor Ratan Lal at the Ohio State University, which I think really sums this up. And it's on there on the screen. Without soil, there can be no life. Without life, there can be no soil. And I think that really does sum it up really well. But we've got this soil material which is complex, it's highly variable, it's this living system. And it is important and critical to our lives. And you can see that on the right of the screen there from the Millennium Ecosystem Assessment, just how integral soils are to this sort of full range of ecosystem services that we need for our survival. It's as basic as that, really. And so we have these challenges, maybe 3 key challenges. You could maybe have a longer list, but we've got to mitigate and adapt to climate change. We've got to protect biodiversity and support nature recovery, and I suppose ultimately ensure our well-being. And the reason for sort of going through that is that absolutely at the center of this and key to this is soil health, and it's key to the solutions to the problems that we're facing. So I suppose that then brings the conversation on to what is soil health. Um, and to understand this, we've got to see soils as this complex system, as I've said, complex and living system, but also as just one part of the sort of complexity of the natural environment system. And so, I put a figure on the slide there, which is the soil map of the UK. And there are over 700 soil types identified just in England and Wales, and they will have a range of properties and characteristics. And essentially, the soil at any given location is a unique representation of those soil forming factors. So we've got geology, that's solid and drift geology, topography, climate, how the land has been used and how it is being managed, but also time, what's happened in the past, what's happening now, and then that allows us to start thinking forward and what might be happening in the future. And this concept of systems thinking is highlighted in a range of documents. I've sort of pulled out there a very relevant one, which is the supplementary evidence report to the 25-year environment plan. And it really just kind of shows that we need to be understanding soils, but not just as a uniform single type material, but as this, as I said, this complex system. And so we need to understand that system as well. But I suppose if soils are that complex, how do we define soil health, and how do we make it a meaningful concept? And I won't go into sort of the detail that, there's lots of work going on at the moment, lots of people around trying to define soil health. What does it mean? What are the metrics associated with that? But I think if we step back from that a little bit, I quite like the conclusion from this paper by Professor Paulson, and he's concluding that actually it is a helpful concept, especially and particularly when it's a conversation starter, when it's an entry point to further discussion around soils, around their characteristics, their nature, the impacts that have happened to them, and what they're delivering for us. But and he concludes also that we shouldn't try to turn soil health into an art form. And if we have that concept that soils lie at the heart of delivery of all ecosystem services, then we need that system to be healthy. But also then at any given location or any project, there may be a smaller subset of services which need to be delivered or can be delivered. And if we have this conversation around soil health as a starter to getting into what are those, how do they deliver, what do we need for those delivery, for that delivery, then I think that's a really useful stance to take as well. And if we're talking about soil health, then we have to also then, as I said at the start, look at the pressures that soils have been under. And it's estimated that around a third of land globally is degraded. We're seeing huge volumes of soil being lost to erosion, and that's not in some foreign country, but in the UK, soil erosion is a major problem. And the Environment Agency State of the Environment report on soils in 2019 stated that the cost of soil degradation in England and Wales alone was £1.2 billion every year, which is, you can't really comprehend that sort of scale of cost of money. But also thinking about what could we do with that if we weren't spending it on, the issues around soil degradation. And that cost, I think, is calculated from both the, cleaning up things like silt-laden runoff on roads and in drainage systems, but also the loss of carbon, the reduction in productivity, soil compaction, soil sealing, and so on. And many of these pressures come from construction, come from the activities required for development. And in that same report from the Environment Agency, it stated that in 2016, 58.7 million tonnes of soil was removed from urban areas and to facilitate that development. But huge volumes of that are going to landfill. So they're not being reused. All those services that they're providing are being lost. And again, the figure for 2016 was 28 million tonnes of soil being sent to landfill, which is just mind-boggling, really, as well. So what do we need to do to turn the tide and ensure that our actions sort of truly recognise the importance of soils and how they underpin everything that you can see on the slide there, and that recognition of that life in soil as well. So, a teaspoon of rich garden soil can contain more organisms than there are people on the planet. And Jess and Sam are going to give us some sort of more sort of detail on specific case studies. But essentially, from you sort of step back from the detail. We just need everyone who is planning the soils, working with soils, to be engaged, to be informed, and to be proactive in support of soils and having these sorts of conversations as well. But we do also need policy and legislation, and unfortunately we don't have the legislative framework around soils, so we are reliant on policy and what comes out from our government. And I just want to focus on perhaps two key pieces of what current policy direction. The first is the Environment Improvement Plan. This was published in 2 years ago, 2023, and given the sort of historic reluctance of governments to talk about soils, possibly mainly because essentially their soils are privately owned, but also the risk of, you talk about soils and you open up conversations around contaminated land and sort of legacy contamination. It was really encouraging to see in the EIP the term soil used 69 times. And there were some really good sort of strong commitments in the plan. I'll put some on the slide there. So, bringing 60% of agricultural soils into sustainable management by 2030, to establish a comprehensive baseline, which again, we lack large volumes of data around soil. But also then to prevent soil resources being sent to landfill as well. But everything kind of set in this concept, this overarching concept of improving and protecting soil health. So essentially to understand how we deliver this, we've got to understand soils, we've got to plan for their best use, we've got to plan for healthier soils as well, so that we can really kind of maximize the benefits that we're achieving from these. And the EIP made a commitment to publish a land use framework in 2023. It's now 2025, but the government have now published their consultation on this, and they've committed to publishing the framework this year as well. Maybe we're taking a step back, it's just a consultation document, but very, very few references to soil in this. I think I did a search and just came up with two references to soil. But actually, when I read the wording, I think we need to take this reference to land, which they do use, that it has to include that critical component, that aspect of soil. And I've just pulled out a few paragraphs that I think are really important. These are just from the introduction. So they start off with that our land is our greatest natural asset. And with that comes this reference to all who work on and look after land and make decisions about land use are central to its future. And then we've got this comment, the land can do so much at once. And that brings us back to that conversation around ecosystem services and the way we can layer benefits from just a single plot of land. And then we've got this reference in the sort of the vision here that land in England is changing in response to the climate and biodiversity crisis. And this is both changes as a result of climate change, but also it's going to need to change in how we deliver on mitigation, on adaptation, on resilience to climate change as well. And Jess will come back to this in more detail, so I won't linger on this, but really we can't just be thinking about soils when we're at the point when we're digging them up and we're moving them. We've got to be thinking about soils and planning for soils all the way through the sort of thought process around a project, because the earlier we start the conversation, the better the outcome will be as well. And in relation to that, I said I'd used to use one sort of project example, and that's Langgarth Garden Village in Cornwall. And this first slide is just some snips from their website, but this is, I think this final sentence here is really important, that they aspire for Langgarth to be a place where people will live, work and thrive. And in order for the project to deliver that green infrastructure within the project needs to function, needs to be healthy, but also the delivery of the project has to ensure it's made best use of the available soil materials. And so very early on in this project, we undertook extensive soil surveys to understand the resource. But the real critical point, I think, in this is that with the client, we developed a soil strategy, and that was submitted with the original planning application. And what that means now is that all future stages of the development, all further aspects of that, they've got to come back to that planning document. And that allows the conversation to drive towards real, true planning for soils, true engagement around soils, and making the best use of this material for all the benefits it gives us as well. So just in summary, before I hand over to Jess, we've got challenges in this era now that we're calling the Anthropocene. We've got to resolve this. We've got to recognise the importance of soil health. We've got to push for strong policy and legislative drivers. And we've also got to have more of these conversations that we're having today to drive engagement, interest, and knowledge around soils. And that come back to the title of the webinar, that critical role they play as well. And so I'll leave it. I do want to thank two of my colleagues, Aidan and Ian, who have been very supportive from different perspectives on sort of driving the conversation, developing the narrative around this concept of championing soil health in the Anthropocene as well. So I will leave it there, and I'll hand over to Jess.
Amazing. Okay, thank you, Bruce. So let me just try and get my presentation up. Okay, so Bruce, you laid a wonderful kind of foundation there, and I'm going to look to build on and explore the value of soils beyond just their material properties, and examine how we can maximize soils and their reuse in construction, and by doing so, how we can unlock opportunities to deliver significant ecosystem services and biodiversity gains. So we'll go building on from where Bruce left off. We're going to explore soils and placemaking, the importance of a soil management plan, and then look at a case study where we'll examine one of our projects where a bespoke approach to soil reuse was used, and then look to draw it all together with some concluding thoughts at this point. So as Bruce has set the scene beautifully, so we'll shift our focus now onto the on-the-ground solutions. How can we better value and manage soils in construction and development? So, as we've already mentioned, too often soil is treated as an afterthought, a material to be stripped, stockpiled, or removed, rather than an asset to be carefully managed. But soil is far more than just the dirt beneath our feet. It plays a crucial role in creating sustainable, resilient, and livable places. Healthy soils provide a foundation for nature-based solutions, helping to address major environmental and societal challenges. And it can support a full range of functions from carbon sequestration, stormwater management, biodiversity, food security, and urban greening, just to name a few. But beyond these environmental functions, soils also contribute to placemaking, the way we design and shape places where people live, work, and connect with nature. And by integrating soils into planning and design from the outset, we can create healthier, greener, and more resilient places. And it's a shift in perspective from viewing soils as a waste to recognizing its value that should be the heart of sustainable development. But just how do we do this? We know that soils can have significant influence and the contribution towards nature-based design and placemaking, but how do we ensure that they're accounted for? So there's still work to do in this sphere, but it's about making sure that soils and their value are accounted at every step of the process, from the initial planning phase and conducting soil assessments so you can advise on micrositing and design changes, through to the development of strategic and bespoke handling methodologies as part of a soil management plan, and ensuring that personnel are clued in and educated and held accountable throughout the life cycle of a project. By taking a proactive approach, we can try to prevent soil degradation, optimize its reuse, and fully integrate it into the wider sustainability goals of a project. And a key tool in achieving this would be a soil management plan or an SMP. An SMP is essential for ensuring that soil resources are handled correctly, avoiding unnecessary degradation and loss. And there are several key pieces of guidance that underpin good soil management. including the DEFRA Construction Code of Practice for the Sustainable Use of Soils on Construction Sites. And this provides some best practice recommendations. And alongside this guidance, soil surveys, as Bruce has mentioned, play a crucial role in conducting those baseline assessments before any work begins. And with this, we can map soil types, assessing structure and nutrient levels, and therefore we're able to inform appropriate handling and reuse strategies, as well as feeding into landscape and B&G designs. And all of this pre-construction information will feed into the development of a soil management plan. In addition to those baseline soil survey information, an S&P should also include several key components, from mitigation measures, where we address risks such as compaction, erosion, and possibly even wet weather working, through to handling and storage guidance, specifying how soil should be stripped, stored, and reinstated to prevent degradation, and then reinstatement and monitoring, and ensuring soils are effectively used post-construction and supporting biodiversity and landscape objectives. By implementing these strategies, we can maximize soil reuse, minimize off-site disposal, and ensure long-term soil functionality. So by understanding the life cycle of soil management, we can highlight the key stages where thoughtful planning and action can maximize its reuse and its benefits. So by taking all of this into account, we can now look at a case study where our strategies were successfully applied in a real-life project. So we've got Poynton Relief Road, which was a highway project just outside of Poynton in northwest England. As part of the agreed landscaping design, there are extensive areas of species-rich grassland required in order to meet the biodiversity requirements for the project. But the original site was ex-agricultural, and as such, the soils contained high levels of various nutrients. And thus, we had a surplus of nutrient-rich topsoil, at risk of requiring off-site disposal, the easy option, but this was against the aim of minimizing waste through the on-site resource optimization. So by leveraging expertise in sustainable land use, environmental stewardship, and circular economy, we developed a bespoke way forward. So we firstly looked at the parameters required for species-rich grassland, and then we examined the values of these nutrients in the available material. At this point, the material had already been stripped and stockpiled by the contractor, with several areas of the stockpiled materials were then sampled. Across the majority of the tested parameters, we can see that the values fall within the accepted range for species-rich grassland. However, we also need a phosphorus level that should be low or very low, with an index of 0 or 1, and the levels of extractable phosphorus detected in 3 of the 4 samples fall outside of this recommended limits, exceeding the threshold of 16 parts per million. So, just to recap, we've got over 15,000 cubic meters of topsoil that require on-site reuse, a planning condition that requires species-rich grassland, and initial testing showing that the Site 1 topsoil materials weren't suitable for the proposed end use. So what do we do? So a decision was made to dilute the nutrient content. So this was done by recommendations of mixing topsoil with nutrient-poor subsoil materials to dilute these overall nutrient concentrations. Due to the high levels of phosphorus, we recommended a mixing of a 1:2 and a 1:3 ratio in order to see which one worked best. And prior to applying and prior to deciding on the specific strategy, it was recommended that these ratios of soil materials were further tested to ensure that the plant available nutrients fell below the upper thresholds. And so this is what happened. As we can see here, we've got the values for the 2:1 and the 3:1 mixing ratios. And here we can see that so this was all done under the guidance of the Environmental Clerk of Works. And we found that employing the 3:1 mixing ratio reduced the phosphorus low enough to become limiting. We have noted that across the nutrients, we do have some higher levels that do exceed the recommended thresholds. And we are believing that this may be due to parent geology, contamination from construction materials, such as cement or drying agents, or potentially potentially leachate accumulation. But since it's seen in both mixing ratios, it's potentially assumed that this comes from the subsoils present. We then conducted, on top of this, one last round of assessment, checking the soil nutrient levels post-application and after planting and after the first grass sward had established. And so last autumn, we went back to the site and conducted our final assessment. And our final assessment showed that the nutrient profiles were somewhat similar to those in our proposed mixing ratios, therefore suggesting that the soil mixing was successful in reducing phosphorus to enable it to become limiting enough to allow species-rich grassland to establish and thrive. And whilst there are certainly some variances in these results, they are on average within the realm required for successful landscape establishment. And whilst not perfect, this approach was successful. We produced something bespoke that not only supported the required planting regime, but significantly reduced off-site disposal of Site 1 soils and exceeded the client's expectations. So the reuse of on-site soil resources is a vital strategy in major construction projects, enabling developers to minimise waste, reduce dependency on imported soils, and create biodiverse and functional landscapes. By focusing on soil reuse and tailored soil management practices, projects can align with sustainability goals while optimising environmental and financial outcomes. The careful management and reuse of on-site soil resources present present a transformative opportunity for major construction projects to drive sustainability and to foster biodiversity efforts. By viewing soils not as a waste, but as a valuable resource, developers can align construction practices with evolving policies such as B&G and circular economy principles, whilst delivering meaningful environmental and soil health benefits. We need to encourage the adoption of a soil-first approach, prioritising soil assessments and reuse strategies from the outset of a project, and find ways to integrate soil management into every phase, from planning all the way through to post-construction aftercare. And by embedding soil stewardship into construction practices, the industry can lead a way forward in addressing global challenges such as biodiversity loss, climate change, and resource depletion. Healthy and well-maintained soils are the foundation of sustainable landscapes and thriving ecosystems, offering a legacy of resilience and prosperity for future generations. We need to see soils not as a challenge to overcome, but as an opportunity to build a greener, more sustainable and resilient future. So I believe with that, we're going to move on and pass on to Sam, who is going to talk more about soils on construction sites.
Great. Thank you, Jess. Right, I shall just go through the palaver of sharing my screen, so bear with me. Right. Just working from the beginning. There we go. Yes, so thank you. I'm probably going to be echoing and certainly hope to be echoing many of the comments or thoughts that have been raised already by Bruce and by Jess, but taking it from the practical on the ground experience that I have working in the construction sector. First of all, I have to confess, I'm not a soil scientist. I'm an ecologist and arboriculturalist by training, and I'd like to think of myself as a very keen soil advocate. So I'm not going to claim a specialism in this regard, but definitely very much recognise the significance and importance this has. So, if you haven't heard about BT, we build large construction projects, by and large, so infrastructure, road, rail, power stations, and so forth. The common denominator there is they're big, and they also therefore have large impacts. And the management of soil in this regard can be particularly challenging. There's some specific challenges which we face regularly. Firstly, we have a defined boundary. Of course, all projects have that, but often, particularly with linear infrastructure, there's an incentive to work as almost right up to that boundary edge. And so space and spatial limitations can be a real challenge, particularly when you're trying to adhere to good practice regarding soil management. So when you're trying to make sure that your stockpiles are of the correct size and that you're segregating them correctly in terms of separating different types of soils and subsoils and topsoils and so forth. So the spatial constraints can be very challenging indeed, particularly when you're trying to retain everything on site, either completely or as much as possible. There are also program constraints, particularly when it comes to handling soils. Obviously, projects are live all year round, but there are favourable and less favourable times of year and weather conditions to moving soils, and so there can be program problems and budget issues as well. This is particularly the case if you are promote practices which might be unfamiliar with some parts of the team or with some disciplines. And if they are perceived to be more expensive, at least in the short term, then you can run up against issues there, particularly if those costs haven't been allowed for in the early stages of project development. These large projects are, by their nature, multidisciplinary. So there are numerous moving parts. You'll have obviously earthworks people, but you'll also have environmental, you'll have drainage, you'll have structural engineers and so forth. There's numerous different disciplines, and all of those have some relationship or to the way the soil is managed on that side. And therefore, getting a cohesive approach can be very challenging. And also, the soils themselves can have more than one function. So, obviously, from an environmentalist, I'm thinking about them primarily as a resource in and of themselves, but also as a medium from which we will be establishing and growing habitats, creating habitats. They may well have engineering purposes as well. So, for example, you could have a batter, which is going to be planted up with shrubs, but also maybe supporting as an embankment a road on the top. And therefore, we want nice, fairly loose soils to be optimal for root development, whereas the engineers will want those soils to be compacted as hard as they possibly can for the engineering function it has in relation to the highway infrastructure. So you can have these kinds of these problematic multifunctional issues. And this is a point Jess already raised as well, but there is a crucial component of having buy-in, awareness, letting people know that getting that transition from seeing soil as muck or dirt, but actually recognizing that it is a precious non-renewable resource is a challenge. It's a shift in mindset, which is we're in the early or mid stages of achieving. It isn't common and widely accepted to be the case in the construction sector. And then finally, of course, you do have compliance. So you can have the greatest soil management plan in the world and all the data there, but it's making sure that everything is actually adhered to as it should be can be a challenge as well. So all I'm going to do is just use 3 different case studies to sort of talk about some of the lessons that I've learned working on construction projects in relation to soil handling and some of the lessons I think might be worth sharing with this community. So our first case study is a road in the southeast of England where there was quite a large component of the project involved soil handling. We had some very interesting dynamics going on to do with ancient woodland soils, but also even just on the main line itself, there was a lot of challenges around being sustainable in our management of those soils for their long-term use, particularly because of we were in an area of outstanding natural beauty, and there was some very tight requirements regarding the habitats that we were going to be creating on that side. So initially, the project was handling soils very much as a traditional muck handling exercise, and it was about moving materials from point A to point B, where they're going to be optimized and where they're going to be used. And this is the kind of the traditional earthworks type of plan that one might see on these large projects, which as an engineering exercise is all well and good, but it doesn't really tick the box in terms of handling the soil for its habitat value or habitat creation value. So what we did was we worked with the engineering team to enhance their soil handling plan in terms of the engineering components, but to think of it in terms of how we manage those topsoils so we can utilize them most effectively for the later structural creation of these different habitat types. So really mapping what the soils were, where they came from, and where they were being stockpiled to then later be reused on our site. It's worth noting we had different types of soil, so there was quite an interesting split between clays and sandstones, sandy soils. So we wanted to make sure that we're using the right soils and we weren't intentionally mixing these soils up. We also had a specific landscape design, as you might expect, with quite distinct different habitat types, which obviously have got themselves different soil requirements. Particularly, we had areas of heathland that needed to be created, areas of species-rich grasslands, areas of tree and shrub planting, and then areas which were sort of amenity grass and highways mix, sort of standard seed mix. So what we did was we worked again with the engineering team to create a simplified version of the landscape design, which could be taken out by the engineers, and actually the foreman had copies of these. And it very, very clearly broke down exactly which soils need to be put where and how they needed to be treated. You know, did they need to be broken up? If so, to what depth? Could they be compacted? They mustn't be compacted, or whatever different management requirements they were. But this proved an absolutely invaluable exercise for helping get that communication out from our designer through the sort of project leadership into and onto the actual ground, so the people driving the machines were doing what needed to be done. And the great thing about this as well is it provided us a mechanism to audit, because there was no excuses. We knew that they knew what had to be done, and then we could go and check that it had been done. So the same document became a sort of audit file for us to ensure that works were delivered exactly as they needed to be done. And this little picture from that scheme, you can see there's two different soil types we have here. So on the left of the screen, we've got sort of the relatively nutrient-rich. All the soils weren't that nutrient-rich, by the way, but they're relatively more nutrient-rich topsoil for the tree and shrub planting, and that this amenity highways mix is going to be at the front there. And then the paler soil to the right-hand side and in the background was for the creation of species-rich grassland, and that was using the uppermost layers of the subsoils, which had been extracted during the earthworks operations. And actually, you can see from or you may be able to see where those sticks are, which are destined to have trees planted next to them, shrubs. We actually, because of the nutrient impoverishment for those soils, we managed to secure extra funding from our client to add additional organic material to those planting plots, which wasn't actually included in the original design. But it's quite effective. And so where we have the tree and shrub planting, that's establishing very well. This photo is quite a few years old now, so it's actually looking even then, so you can't really see that fence line anymore now. And the species-rich grassland has also thrived there as well. So moving on to the second case study, this was an exciting project because soil had been given such a high priority from the very start, even before we were contracted to undertake the work. It was so there were very specific legally binding biodiversity commitments, and BNG was used as a measure, but it wasn't actually BNG as such, because this was before any mandatory BNG had come into force, and it wasn't actually done through DCO or the Town and Country Planning Act. It was a different mechanism, consenting mechanism. But either way, the important part of that was that specific habitats were a requirement within the planning consent project. So they were baked in very early on. And also, as a result of that, there was a recognition of the importance of the soil and a prioritization of trying to utilize as much of the Site 1 soil that we possibly could. So again, as in the previous example, it was about mapping what we had and making sure that it was deployed exactly correctly and handled correctly in the right locations. To make this work, it was very, very much a collaborative exercise. So early on in the project development, we grouped together our experts from our design team, the stakeholders. So there were third-party landowners in proximity of the scheme who had a very vocal and important interest in making sure that these habitats were delivered as specified. Our client was very keen on this as well. We had an in-house team of project ecologists, which is excellent because that gives us that regular interface with the construction team rather than relying on consultants all the time. So they were embedded fully throughout the duration of the project. We called upon soil scientists at different stages. So there were some soil scientists that were working with the design team early on, but then later on as a project, particularly when we ran into some problems, we engaged with soil scientists to support us to help understand and interrogate the situation to come up with solutions. Vitally important, we worked alongside our construction colleagues. So it wasn't a matter of just being an engineer or an environmentally led exercise. It was a full delivery team engagement. So we worked with engineers, with the leadership of the project, and also, again, with people out on the site. And also vitally importantly, we incorporated and brought in our landscape contractor very early on for their support and their guidance, because ultimately they would be taking on the risk to a large degree, and they needed to have confidence, and we needed to have confidence that we were going to be able to establish those habitat types. So I can't emphasize strongly enough the crucial role that having this really integrated and collaborative team was in order for us to proceed with any degree of success. So image of some of the stockpiles we had. These were all monitored to make sure that we were keeping things segregated and we weren't mixing soil types up, and then they could be redeployed as they were needed. And we did regular soil testing, particularly when we did run into problems because some of the soil types weren't really what we needed, and that we had to work with soil scientists and experts to try and find a solution. And some of the solutions were very similar to ones that Jess was talking about earlier on, actually, about blending materials together. And by and large, it's proven to be very successful. So we have created quite a large amount of online and offline habitats of the different qualities that are required and different habitat types, which is very exciting. And I would very much like to give a special shout out to Dr. Phil Sterling, who some of you may have met. He was an absolute legend in terms of a person that I and my team could get in touch with very regularly to try and get help with overcoming these sometimes seemingly insurmountable problems. So thank you, Phil. We wouldn't have been able to do it without him. Our third example is from a project which is still in construction, and this is in a very sensitive area. So we have SSIs and SPAs and other issues as well. So and soil is a high priority on this site. And we've taken the learning that we had gathered from those previous projects and elsewhere in the business to try and ensure that we dealt with problems or identified problems before they came about. So what we've done very significantly on this project is try to introduce processes and systems to enable really optimized handling of the soil and that accountability to make sure that it's not only that we are doing the right thing, but we can check, and if something wrong is being happened, why, how, and put it right. So now we're not working on CAD drawings really anymore. So this is all digital 3D modeling. And this is basically working the same way as our crude annotated CAD drawings were, in that on the model, you can click on different parcels and it'll tell you what the landscaping design is for that area, but then also crucially what the soil handling needs to be on that area as well, whether it's a topsoil, a subsoil, a nutrient poor subsoil, the depth it needs to be laid, how it needs to be broken up and handled, and so forth. So these are just on this one little area. There's 4 different types of soil handling protocols associated with it for those reasons. It's entirely on end habitat use mechanisms. And what we've also done is used a system of soil passporting. So that is a way that every single time any soils have been stripped, handled, moved, stockpiled, and then reapplied, that we have got a full auditing system to make sure that there's full accountability. We know exactly where things have gone. This site has a large different array of invasive species on it as well, which obviously has extremely important considerations in regard to how we're segregating our soil stockpiles. And this has been an absolutely invaluable process. This is filled out by and large by ground operators, so foremen and people of that level on the project. So what we did, and again, this harkens back to what both Bruce and Jess were saying, is about engaging as early on with experts and getting soil prioritized as early on in the development of the project as possible. So we worked with a soil consultancy to develop these passports, but then also to roll out training for the different operative teams, so that the individuals felt sufficiently empowered and able to make these kinds of, they're kind of crude and basic level, but they still require knowledge and understanding in order to fill them out. So and that also helps with the raising awareness and getting buy-in from people, which is obviously vital. So I went through those challenges that our projects face, and I'm not going to pretend those challenges have ceased to be. They very much are still pertinent on every project that we work on. But there are ways that you can manage them effectively that we've learned. So the three things I'd like to focus on to end this with is the need to collaborate, to recognise that on large projects in particular, and probably all projects, that multidisciplinary approach really does pay great dividends. You are all ultimately working to the same goal, which is successful project delivery. Making sure that specialists are engaged with as early and as consistently as possible, particularly when BNG becomes mandatory for NTIPs, making sure that our soil scientists and our BNG and biodiversity experts and landscapers, as well as our engineering, we're all working together and we're getting that specialist input as early on as we possibly can and regularly during the course of the project. And making sure that you do have adequate processes, especially in very large projects. There's so many moving parts, you can't be everywhere at once. So you have to rely on having robust systems in place that you can rely on to make sure that things do run effectively, making sure that people are adequately trained to undertake the tasks you're asking them to do, and then that there is this accountability so that people realize that they are putting their name against things. So that's me.
Thank you, Sam. Thank you, Bruce and Jess as well. So I think if everyone's got their cameras on from the panelists, thank you. So yeah, we'll just go through a few questions now. We've already got a few in the chat, but feel free to add some more as we're going through them. So the first question from Lindsay was just looking at whether or not we sort of have any guidance on what level of soil testing or other data should inform a habitat bank application to an LPA, and sort of what reference documents are available for LPA ecologists to refer to. So I think maybe either Bruce or Jess, if you could respond to that one, please.
I can come in first. I guess that, there was some good Natural England guidance. So there's the technical information note TIN 035, which is all about soil sampling for habitat creation and restoration. So that might be a useful starting point in terms of both how to sample, number of samples, and what testing and what the key criteria. But really also then it's about perhaps coming back to understanding the site-specific conditions, the soils and the habitat that is either there or is proposed. And whilst not currently available, there is within CIEEM a special interest group who are developing guidance essentially that will hopefully give you some of this information. So I've been writing one part of the guidance which is around the physical environment, so about the things you need to understand from a physical environment perspective for your site. There are some other overarching documents, and then the next phase is then, which is in production, is producing habitat specific documents, which will talk about the sort of key characteristics you need for any given habitat as well. So that is still to come, but I think that will be a really useful, highly useful set of documents.
Thank you, Bruce. So looking at a question, I think mainly towards Jess, it was just around the cost of sort of soil mixing compared to disposal of sort of topsoils, and whether or not developers are sort of prepared to commit to these additional costs, or whether there would be additional costs.
I guess kind of obviously the easiest, probably the cheapest way to kind of manage it is to kind of almost, obviously difficult with the project that we're working on, but to almost roll it back to that beginning stage to ensure that that landscaping design matches with the soils that are already on site. What we had in this case is obviously trying to retrospectively create a soil matrix that would support the planned and approved designs. If we're able to obviously have that soil information up front and to create and put forward designs into planning that are then approved, that can be supported by the soils that are already on site, we then don't have to look at disposal. We don't necessarily then have to look at mixing. It's about working with what the nature and what the landscape has to offer. And that's obviously, in the grand scheme of things, requires the least amount of additional inputs. And yeah, we have crazy amounts of soil going to landfill. So trying to find ways that stopping soils going to landfill and utilising what we've got on site. Because it's also not just about the material cost, it's the time cost, having to remove stuff off site, import new things onto site, programs extend, and that all adds to it. I think kind of in terms of actually the cost of doing stuff on site, Sam's probably a little bit more clued up to some of that than I would be.
Generally speaking, it's cheaper if you can just use what you have there. I think I completely agree with you, Jess. Yes, it's vital. You are in a much better place if you've got a design which is reflective of the soils that you have than if you're trying to, create something which nature is fighting against. But generally speaking, if you can retain and reuse your soils on site, it might be complicated because of the spatial dynamics that I was talking about, which can create problems. But yes, usually it's cheaper, and obviously there's a sustainability piece, which of course it's you don't want to be throwing away a non-renewable resource. But also there's the carbon. The carbon involved in haulage and moving this stuff around, let alone the carbon involved in the damage and where it's coming from, the source side and everything else. There's so many reasons, financial reasons, to try and keep stuff on site as much as you possibly can, as well as good ecological reasons.
Thanks, Sam. I think also we'll follow on one more question for you, was just regarding how you sort of manage the existing seed bank in soils and whether or not you do any analysis to see what's there or just sort of waiting until establishment.
Okay, so that's an interesting one. So obviously we're working, all the projects will have had environmental and ecological impact assessments before we start. So we'll have a knowledge of the plant communities that are there before we've begun. And again, good design should be incorporating an awareness of that into it. It also depends on what's the end use going to be. Sometimes that's not as much of an issue. Sometimes it is an issue. Sometimes you're really desperately trying to preserve the seed bank. In the case of wood and soil translocation, obviously that is your priority. When you're trying to create species-rich grassland, if you've got a soil that's too nutrient-rich, then the seed bank is probably going to be a problem. And then it's a matter of working out how you manage those soils to try and reduce the burden of maintenance to establish what needs to be established, whether it's the blending methods, whether it is chemical treatment, which we try to avoid as much as possible, or what other methods. But I think informed design can help greatly. But yes, it depends is the answer, which isn't a very good answer, but I think it depends.
I maybe just add to that. I know we're very close to time, Liv, but I absolutely agree, Sam. It also then, and I think I'd like to see more seed bank trials done on projects where soil reuse is being promoted and promoted, because obviously seed bank will change over time in a stockpile, and you'll have some seed which is more resilient. And I've worked on projects where we've been trying to maximize seed bank, but rush in the reinstated soils has dominated because the rush seed has persisted, whereas other species the seeds have gone. So yeah, it's a complex one, but I think it'd be great to see more seed bank trials and more understanding of seed bank.
Thank you all. I think we're probably running out of time. I don't know whether maybe you just have time for this last question, which was just regarding if a site only has sort of classified bad soils, are there any other options other than diluting the soil or sort of bringing soil from elsewhere? So if we could have just a quick answer on that one, thank you.
Shall I go first? Interesting concept of bad soil. I would possibly first come back to that and say what is wrong with it, because actually, if we ignore contamination, soil quality is a term which isn't used so much because it's difficult, because actually a soil that's best quality for a wetland is not going to be a soil that's best quality for, you know, high value horticultural crops. So understanding what you mean by bad, and again, this comes back to maybe the question is, how do we align our sort of post-construction habitats or landscaping with the soils that are there, and not try to work against that.
Thank you, Bruce. Thank you to all of our panelists and sort of for everyone for joining us today. I think if there's any questions we didn't get around to, or sort of if you have any questions at all, then please reach out. I think, yeah, we'll try and get back to you. But I think we'll leave it there before we use up too much more of your time.
Brilliant. Thanks, Liv. Thanks, everyone.
Yes, thank you.
Thank you.
Thank you.